Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before I introduce today's guest, let me tell you just a little bit about this podcast if you're new to it. As you think about the paradigm for data creation and data access, it's really changed over the last 30 or 40 years, ever since the advent of the first big enterprise computers like from IBM, where a building, a facility, and the people all really rotated around the compute environment. We've become very distributed as a world. We have the cloud, we have remote workers, we have a global economy, and data is being created everywhere on sensors, autonomous vehicles, satellites. And this podcast really focuses on how do we identify and get access to all that data? How do we put it to use? And what are some of the challenges as well as the solutions to help as you're on this journey? Today's guest will certainly have a lot of insights into this area. Karthikeyan Rajendran is the Director of Go-to-Market in the NVAIE Group at NVIDIA. Karthik, thank you for joining the show.
Thank you, Molly, for introducing me. I'm happy to be on the show. I'm looking forward to share some of my learnings and insights.
So before we talk about NVIDIA and what you do at that company, which I suspect most of our listeners is somewhat familiar with NVIDIA, but maybe not about the NVAIE Group, which I am just learning about myself. Tell us a little bit about your background, if you wouldn't mind.
Sure. Yeah, I have a master's in electrical engineering. I started as a hardware engineer at Qualcomm before I realized I like to involve myself more on the business side and see how I can help companies like Qualcomm or even now NVIDIA, how to go to market with not just hardware, but with a full stack solution. Towards that, I do have an MBA from UCLA Anderson. For the last 6 to 7 years, I'm here at NVIDIA. NVIDIA is a great place to work, primarily because I wore multiple different hats. I started out as a technical product manager before moving on to more of an external facing product manager in the business group. Now actually I'm part of what we call as a worldwide field operations, which is other words sales operations or a sales group where I lead go-to-market for NVIDIA AI enterprise software. The goal is for NVIDIA enterprise software, it's almost an equivalent of an operating system for the Gen AI. When I mean operating system, and that's why I want to share more about that, all the way from how do we help customers process the data, curate the data. Once they curate the data, how do they customize the model or create a model, and then all the way to deploying the model. Doesn't matter where it is, if it's on your laptop or on the cloud or on hybrid.
So I have a kind of similar path. I came from the engineering side. Now I've run marketing for my company, but it is interesting to see in the technology space that's difficult to do almost any job if you don't have a fairly technical background these days. So it serves you well, whether you're in marketing or biz dev or go to market, really understanding the technology and how customers are deploying it and the subtle differences, we'll talk about this later, just the basic things like a GPU is not just a GPU. That's not just one thing, and understanding the differences for sure. So I'm sure that served you well. So tell us about the NVAIE Group at NVIDIA. What is your mission within, a fairly large, dominant company?
Yeah. So you can think of NVIDIA as full stack company, right? When I mean full stack, basically you can think about three things, right? One is the hardware layer itself, which is basically the chips, which can be a CPU, GPU, or a DPU, which is for data processing unit. And that's the fundamental layer. And the second layer on top of it is what we call as the base code libraries, be it CUDA, cuDNN, or even PyTorch. That's the second level of abstraction where it'll let you program. Again, it doesn't matter what hardware you have underneath. It gives you the application interface. And the third level is what we call as the intermediate application layer, where customers all the way from let's say ServiceNow to Salesforce, or today even OpenAI, writing applications, and we provide some of the fundamental libraries for these applications. For example, just in data processing space, right? We have an open source library called Rapids, which can help you do data processing with cuDF, machine learning with like cuML. And then we also have the libraries that are specifically used for data loading, like images, because today there are terabytes of images that are loaded every day coming from autonomous vehicles. So we have a library called DALI, which is nothing but data loading library for images. And then we also have something called now, which recently we introduced, which is called the cuVS, which is the NVIDIA vector search accelerated by CUDA. So the goal for NVAIE, as I mentioned, right, it's an operating system. So we want to develop these libraries and APIs that can talk to each other, because at the end of the day, you want to build applications on top of these fundamental libraries, but also make sure as NVIDIA moves forward from one generation to another, be it like Volta to Ampere to Hopper to like Blackwell, your applications don't need to move, but your applications get faster and faster if you just move to your newer architecture. And that's what NVIE intends to provide to customers, right? A platform of libraries where customers can build their applications and not worry about what hardware or what software dependencies they have to work with.
That's interesting. So you're building the platform of libraries. How do you think about the other parts that go with it? Do you get into like the Kubernetes, the orchestrating the workloads, orchestrating the data? Like how far up and down the stack are you approaching with your platform?
That's a really great question. So we recently introduced NIM Blueprints. What that means is let me first explain what a NIM is, right? NIM is stands for NVIDIA Inference Microservice. For example, there are if not hundreds of models, there are tens of models out there today, be it like Llama 3, Llama 2, Mistral, like Anthropic and Bedrock and what. There's so many different models. Mm-hmm. And each model is like horses for the courses, right? We want to make sure these models are optimized for a specific hardware and specific GPU. Because today, a customer can run like a 70 billion parameter model on a Hopper, but tomorrow if he wants to move hey, there is an Ampere A100 available, we want to make sure the same model is optimized for throughput, optimized for performance, optimized for time to first token or inter-token latency. So that's what NVIDIA Inference Microservice is. But we realized, right, specifically as you asked, hey, how does it work with all these, when I deploy in Kubernetes or whichever environment it would be? So we provide something called NVIDIA Blueprints. So we release 3 blueprints, basically using a Helm chart. So that will help you build, we provide a point of view and as a reference architecture, right, that you can take and deploy. It doesn't matter where it is. This blueprint is basically not an end application, but a reference architecture for an application. For example, we build a digital human that can be used in customer service. We have also built a multimodal PDF extractor. So let's say you have thousands, if not millions of documents, right? Hey, how do I process these PDFs? How do I embed this in a vector database? And finally, how do I ask questions and then and get some really useful insights out of it? So that's where the NVIDIA blueprints come into picture. So we want to work with the ecosystem.
I can't imagine how many there must be of these NVIDIA blueprint requests, at least. So I mean, there must be millions of them you could do across industries and use cases and all that. How do you decide? How do you decide where to focus?
That's a great question. And NVIDIA, it's when I rattled off all these libraries come into existence because of customers asking for it. Hey, we have a specific bottleneck. Hey, we have a specific use case. Can you help with this? And that primarily stems from what a product is born out of, right? And you are absolutely right. Our product managers are overwhelmed with the number of blueprint requests. We have around more than 200, 300 blueprints on the roadmap. In wow. terms of, and we go to business by vertical too. For example, so it's an understatement to say NVIDIA is a platform company, right? Because I just cannot find a better way than it. Because the reason is we work with financial industry, we work with healthcare industry, we work with an automotive, we work with manufacturing, and there are blueprints for each and every one of these industries because the use cases are so different. Mm-hmm. So hopefully that gave you a little bit of insight of how things evolve here.
It does. Yeah, it's interesting. And, a little bit of a peek behind the curtains of, what a company people are very interested in. And a lot of companies are deploying your technologies and, still learning how to deploy. So I think that's a really important bit. So let's take a step back a little bit. GPUs and AI, you almost can't watch TV or pick up an article and not hear about them. But how have, from your perspective, I think you said you've been there 6 or 7 years, how have you seen data science and just kind of data workflows change over the last 6 or 7 years?
I would put them in like 4 different eras, right? The first era is basically like, for the last, like, let's say 20 years, the traditional data science workflows. And that's like almost you can call it as a pre-GPU era, right? For the lack of it, let's say like 2000 to 2006 or 7, where nobody heard about GPUs, or like, GPUs for the lack of like, which is what NVIDIA introduced. GPUs again stand for general purpose graphics processing unit. So the first era, like, if I have to, like, split this into 4, right? The first is the traditional, as I mentioned, pre-GPU era. It's all about sequential processing, small to medium data, focused on statistical models. And those were the key characteristics, right? And then, like, there was not like a need for a big compute because everybody was like, not doing like, again, data was not exploding. And this is where, like, even before iPhone era, right, there were not too much data that's being like generated. All the data were machine generated and it's coming out of the computer. That's the first, like, I would think the first pre-GPU era. But the introduction of GPUs kind of opened up a new space, and which is what, like, people started, like, doing parallel processing for GPUs, and that's where the initial, like, AlexNet came into picture, where they were able to deep learning, they were able to do a little bit of big data, and mostly GPUs were used in high performance computing. That was, like, our initial, like, area where we found a lot of traction because people were able to use these parallel processing capabilities.
So that was kind of the time frame from my perspective when GPUs weren't just used maybe in an end user's machine, but going into supercomputers, right? All of a sudden, supercomputers were being built on GPUs, often instead of CPUs, right?
That is correct. Yes.
Yeah.
And following that era is what I would say the last 6-7 years. I'm like relatively younger in that way, right? The modern data science workflows, and this came about because of, like, couple of key things, right? One is like the deep learning revolution itself, like TensorFlow, PyTorch, Keras, which help, like, almost democratize, like, how to do deep learning. And the second key thing, as you guys, like, pointed out, or you pointed out earlier, right? The distributed computing, the flourishment, or the onset of cloud. And that gave, like, of course, it started the distributed computing, and also, like, access to GPU clusters. Because what used to be just, like, for the HPC or the high performance computing or a few researchers, now actually the general public was able to, like, get access to GPU clusters. And that's when, like, rapids came into picture too, in terms of, hey, how do I, like, run my big data on GPUs, and how do I use TensorFlow, how do I use PyTorch, how do I use rapids to do my data processing. And that's the third era. And the final era, which is probably everyone knows, is the shift to AI workflows, right? Now you got an LLM, and people are, like, asking, like, questions to the database. Hey, how do I, like, there's in my opinion, I know this is a question that also we all have in mind. There wouldn't be a day where we do SQL, right? Because we're going to ask just a question to a SQL database. Hey, tell me the top 10 customers in this zip code who have bought this widget X. And that can be converted into a SQL query, which is what an LLM do, and then, like, go get the data in from the database. And that's the shift to AI workflows. This is, in my mind, that's how it has progressed in, like, 4 different stages. It was a long, winding answer, but hopefully that gave.
But it's interesting because, it's easy to get so focused on, kind of like you say, the latest wave, and yet the others are still occurring too. There's still other types of data sets. There's other types of workflows. They're just not the flashy thing in the news, and maybe not on the agenda of the 2025 executive staff budget planning cycle, right? As we're talking about data curation, there's I think, fairly well-established number of about 20% of data is actually being used. How do people approach identifying the other data, thinning out what they need access to? Do you have some thoughts there?
Yeah, certainly. That's an interesting question, and that's where I think we're going to make tremendous progress, right? As you rightly pointed out, right, almost like 80% of the data is not used. primarily people don't have the compute to curate the data. They literally throw away 80% of the data that they collect. And I believe like data curators and like on GPUs will help bridge that gap, right? Now you should be able to, now you have the compute, now you have the libraries that can help you curate this data in a much shorter time frame. You should be able to like, get insights like, let's say 5 years down, as I mentioned, right? One of the use cases about customer churn. We can look at 5 years and look at like, 5 different Thanksgivings and then say, hey, you know what did I sell for the last 5 Thanksgiving if my weather was like, slightly on the warmer side. And that insight today we don't have because we throw away a lot of data and we don't really go back and see like 5 years ago, like, that's probably a petabyte of data, but you're looking for a needle in the haystack. And that's where data curator will be like, I need these specific data points. And now I have this, can you generate more of this data? And then like, model this behavior. So that way I know, do I need to sell more avocados or do I need to sell more like, margaritas or pumpkins, whatever that may be.
I usually lean on the margarita side, no matter what the weather, but
I tend to agree there.
But yeah, definitely a good point. Yeah, I was talking to a university recently, and they were covering. Think about all the doctorate students who have written their thesis and submitted it, moved on into their careers. If you could just harness what was in those thesis documents, like that, just imagine what has been found there. And it's really been submitted, they've completed their program, and maybe it's not been used extensively beyond there. And it's the same point you're making of just imagine all the data and insights and thoughts that are out there that aren't still, even in the big LLMs, being taken advantage of. So it's got to be a huge opportunity.
Exactly. I completely agree, right? And so like, there can be 1,000 different like documents or even like 10,000 documents, right? The curator will help you like, these are the 10 relevant documents. Everything is probably high quality in terms of research, right? But these are the 10 relevant like, documents. To get to that level, that's where curator is important. And then like, how do you classify, these are the 5 different topics that it comes under. And talking to that data, that's going to be very powerful. So everyone is going to be a PhD candidate moving forward.
Excellent. So maybe if we can talk for a minute. So GPU stands for graphic processing unit. Maybe talk about the different types of modalities of data. Are all GPUs created equal? Do you guys still recommend CPUs in some places? Maybe just talk about different types of data and the different types of processor technologies and how you approach that.
That's a great question. Let me first, address the first question, right? Different types of data. If you look at that, in my mind, at least, like the types of data that we see with our customers, one is like structured data, and in the structured data, you have pretty much like text or like numericals or numbers. And that comes out of like your structured database or like even from your like JSON file from the website, right? For example, let's say you go to Amazon.com or eBay.com, Walmart.com. So there is like a structured JSON data that comes back from every page that you access. So these are the 2 types of data that like in my mind, like it's the first type of modality, right? And if you look at the recommender system and whatnot, that's what it's built on in terms of understanding like the structured and semi-structured data. The second set of data modality is your like images, PDF documents, and whatnot. And that's like basically coming out of again the internet era and also from like mobile devices, right? There's a lot of data that's been generated. That's a second modality in terms of like recognizing a picture and then like recommending more pictures or more products similar to that image. And the third type of modality is the video modality and audio modality, which is very, very, very recent. And that's where like where automotives in terms of training, deep learning training for like how do you train from a video of a series of videos, right? How do you like train like similar to what OpenAI has got for Sora, or even like audio modality. Hey, how do I like use in customer chatbot? So those are the 3 different like modalities, at least in my mind, right? Text, which is all structured and a little bit of like semi-structured. Then you have the second one, which is images, PDF documents, which is predominantly where like most of the enterprise data, and this new set of applications that's coming out, which is basically video and audio data. In terms of are all GPUs like created equal? I wish, and it's definitely there are so many different type of GPUs, right? And we like the number three, and I'll go with the number three, and I'll tell you why it's number three, right? So there are three different type of GPUs. One is that these big GPUs, like everyone knows about the Hopper, Ampere, and the Blackwell that's coming out, and
Sure.
these are great for generative AI applications and deep learning applications. Then you have the second set of GPUs, which are what we call them inference GPUs. Even though it's increasingly getting the lines are being blurred because even a Grace Blackwell, which has got a CPU and GPU, is good for inference. But there's a smaller GPU, which is the inference GPUs, which we have T4s and L4s and A10s. Those are the type of GPUs you'll see on the cloud too, and those are inference GPUs. They are relatively smaller in terms of even the price, right? It's almost 1/5 of or probably even lesser than that of a big big training GPU or the H100. And the last one is the RTX, basically our ray tracing GPUs on your laptop. That you can build your PCs and workstations and whatnot. Those are the three different type of GPUs.
When you think about the three different types of GPUs, and I believe this is an accurate-ish quote from your CEO saying that one of the biggest crimes is inactive GPU, and the intent of that being that they're a bit difficult to get at hold of. They can be quite expensive. Power can be short. There's a lot of reasons why a GPU has value. And I think it's an interesting thing to delve into just a bit, for people listening to the show who are still trying to figure out their data strategies, their AI strategies, that, a less powerful GPU might be just the right thing for you. And then you don't have one sitting inactive that you spend a bunch of money and power on that you're not using. Maybe just talk about, how you think about that as a company, that using 100% of what you have is a good thing, and maybe you don't want a big thing you can't use, putting it kind of simply.
In my mind, right, and I absolutely agree with our CEO, right? Not having a GPU fully utilized is definitely you're throwing away your money. But in terms of data processing, just pure structured and some structured data, if you're just using text, and if you're not really dealing with petabytes of data, you're just dealing with say gigabytes or even terabytes of data. We recommend the inference GPUs are the smaller GPUs, right, which is the L4s and the T4s and A10s. Those GPUs are highly efficient in terms of processing data for two reasons. One, these are in the cloud, and in the cloud there is always a healthy competition in terms of I/O, right? Because you are reading your data from S3, and there you have only certain bandwidth to read the data from. And again, if you are doing distributed processing, you are still on the cloud, and there is only certain bandwidth where you can shuffle this data. So that's why you are mostly bound by I/O, and that's why the smaller GPUs are much more effective in that, because your GPUs, think of your GPUs as a lot, it's a comparison between a small car and having a big truck, right? If you are in the truck, you can take a lot more, but you want to make sure you can load a lot more too. If you're just taking one small package in this Amazon big truck, then you are essentially that's how you should look at a GPU. And so if you're on-prem, we build our own DGX systems with H100 and Blackwell and whatnot. The biggest thing, if you look at DGX, is the amount of I/O that has to feed those GPUs, and the amount of memory and the fast memory that they SSD or even NVMe. And these days there is Lustre, which is basically really a highly fast I/O, and that's what you don't have on the cloud when you have these inference GPUs. And that's why you should go if you're doing data processing, and if you're not really processing a lot of data, and if you're not bound by time, you're just bound by cost and performance, you should go definitely with a smaller GPU that which will give you almost 5 to 10x better performance than CPU, and again, but saving a bunch of cost.
You probably see more of these workflows than any of us do, in a day, and being able to share just some of the kind of the cliff notes of what you've learned over time of how people should be thinking about the different GPUs is helpful. So then you talk about this era of, post iPhone, post autonomous vehicle, where you have a lot of data being generated. And you mentioned you have blueprint type reference architectures. How do you think about or recommend your customers, or do you, on how you get access to that data and get that distributed data to a GPU?
The data strategy is as critical as the compute strategy too, right? And in terms of if we want to get let's assume there are you have a certain goal. For example, let's assume you have a clear objective, right? Hey, I want to predict future trends. That could be sales forecasting or customer churn and whatnot. And the second thing is we want to also understand, okay, now I have this business case and objective very clear, and I want to do sales forecasting or customer behavior. It's okay, what sort of content is relevant? How much what's the right time period and what's the granularity, right? Those are key constraints and key key things to consider before you can say, this is what I want to do. And the third thing is data quality. You could have 6 years of data, but if most of the data is nulls, then you have a problem. So that's why having data quality, making sure you have the right set of data, those are in my mind, the completeness, accuracy, those are very, very critical understanding that. Finally, data volume and structure, right? You can do all this. I'm looking at 6 years of data, and if it's let's say a few petabytes of data or a few terabytes of data, then I know, what, my right strategy should be using GPUs. What are the libraries should I be using? What is my end goal? And that's when you can start thinking about what GPU should I use? What sort of workflows? Does it involve only text? Does it involve images? Does it involve videos? So all those things come into consideration before you can say, what, this is my this is how my end-to-end workflow work like. These are the libraries I'm going to leverage, and these are my compute I should be leveraging. And this is my budget too, because I went to business school. One thing I learned is all ideas are great, but if you don't have an ROI, then the idea never sees the end of light.
Yeah, exactly. So are you hearing a lot about data curation as, a role or a task that's really top of mind? I've been at several CDO type summits here recently, and I'm hearing that a lot, and wasn't a couple of years ago. Curious your thoughts there.
Yeah, so we recently, released, again, as I mentioned earlier, right? Most of our products, if not 100% of products, are of course, Jensen thinks ahead, 5 years ahead in terms of where the industry evolved. But here and data curation is on top of our mind, primarily for two reasons, right? One, there is plenty of data, and there is also lack of quality data.
Absolutely.
For example, let's say an enterprise let's say it's an e-commerce enterprise, or probably enterprise that's dealing mostly with some sort of customer service request, and they need to curate the data to fine-tune their model. That's their number one issue today. I have so much data, but I need to understand, is this data relevant? Is this data quality data? Because you don't want to make sure you have the. I'll give you a good example, right? In our internal workflows, we have few 100,000 PDF documents. But most of the documents are just a little bit of revision of an older document. So if you really look at the quality of data, those 100,000 documents, it might come down to just 1,000 quality documents. So one of the key stages for data curation, or the biggest compute problem you have, is the dedupe. Trying to understand hey, what, how much of this data is qual, and then second is classifying the data, right? Oh, is this design document? Oh, is this customer conversation? Oh, is this sales data? So classifying those data, and then figuring out what percentage of data do you have in each of these domain, and wherever you have quality data but less amount of data, can you use a synthetic data generation? Again, it doesn't come this is part of data curation, because only if you do data curation so very diligently, you'll understand, what, I need to generate more of this data before I can take it to the next level as as a CDO, where I can actually create a model that has high accuracy, high fidelity to my specific use cases or to my specific benchmarks.
Yeah, absolutely. It kind of reminds me of, I've been in the supercomputing space most of my career, and I think this data point is accurate that the Large Hadron Collider over at CERN creates a petabyte of data every second. And of course, they don't keep all of that, but they have software to distill it down to what are the interesting insights from that data. And they've built that over the last, 20 or 30 years. And all the enterprises now are trying to figure out their analog to that of, oh my gosh, now we have so much data being created, but which data is relevant? And this concept of data curation, I think, certainly is how people are starting to tackle that. Where do you think people can learn? I'm honestly curious for myself too. From your perspective, where are the best places to learn about best practices, best tools, maybe what your peers in your industry are doing in this area?
So I personally go to all the data science conferences and leading tech conferences. There's one conference that where we'll have our presence is our Open Data Science Conference West that's coming out in the next couple of weeks in Burlingame. So we have our product manager doing a keynote there, but I go talk to customers there. I'd go talk to practitioners. That's there are several great sessions both on the data science on LLM
tip.
data curator. So that's where because most NVIDIA is an open it's just built on open source libraries. We let the open source community make our libraries better, and what that means is eventually you have to go out there and then talk to people, and they have better ideas than what you can have inside those four walls of your organization.
Yeah, absolutely. And then before we tie up, I wanted to talk. I was just kind of glancing through some of the notes from the prep call that we had, and we were talking a little bit about democratizing access to big compute, and I think that's a topic it would be interesting just to talk a little bit about. So again, the supercomputing world, it used to be only specialized groups and specialized organizations really had access to big compute. They were the ones with time on the supercomputer, and that's really changing quickly. That now having access to big compute is a differentiator for enterprises, is differentiator for governments and their global power, that type of thing. What is NVIDIA doing that is helping in this motion of making big compute more accessible? And I think your blueprints and reference architectures are part of it, but I'm sure there's more to it than that.
I mean, one of the things I'm fortunate to learn from our founder CEO Jensen is, and he's got a singular focus on reducing the compute accessibility to compute, and how does he do that? Right, he as a leader, he drives us to reduce the price of compute every year by 3 to 5x. What that means is, right, for example, this is kind of really out on the left in terms of an example, right? 100,000 GPU cluster or 100,000 CPU cluster can now be replaced by just few tens of GPUs. As in terms of
Is
the
how you
compute
accomplish that 3 to 5x.
How you accomplish that? Yes, yes. And then in terms of cost, that also reduces. If you want, people don't think about when you have 100,000 CPUs or 100,000 CPU cluster, the amount of power and space is just as you rightly pointed out, right? That was only accessible to the supercompute. Now, if we want to really take that, if we can run it on a few tens of GPU, let's say 10 GPU clusters, you can go on Amazon, just rent those 10 GPU clusters, have a supercomputer. You can build the supercomputer by yourself, and then you can do your processing. And then it doesn't really you can rent it by the hour. If you just want to do just for $100, you can rent a supercomputer and then build your own and do it. And that's how we are democratizing. And we're not stopping, right? As we go every year, we want to reduce the amount of compute or amount of dollar per flop or whatever that number would be. So that's how NVIDIA is innovating to make sure it's democratizing in two levels, right? One, we are making sure compute is cheap and it's accessible. And second, we are making sure the libraries are all open source. Doesn't matter what it is. It's Rapids, CV CUDA, or NVComp. So these are fundamental libraries where you don't need to sit down and program this huge these complex computers. You have APIs that are similar to, for example, cuDF is similar to Pandas. QML is similar APIs as scikit-learn. And same thing with QVS and whatnot, right? We make APIs that are that coexist. that makes sure you are not like, you don't have a steep learning curve. And then again, that steep learning, again, in terms of democratizing, an LLM actually can even program it for you or probably give you a starting point, if not completely finished, right? That's why most of the software engineers are able to like increase their productivity. So those are at least in two different vectors: reducing compute cost and increasing the accessibility, like in terms of how to use these supercomputers.
Very cool. So where do you think we'll be 3 or 5 years from now? I know you said that Jensen and just NVIDIA in general are thinking that direction, but maybe your company's name and maybe just your own personal, where do you think we're going to be 3 or 5 years from now? What will we be solving? What will we be tackling?
So at least in my mind, I feel like, data science and GPUs would be synonymous. The combination of like, AI, data science, and GPU, everybody's going to be using GPUs for their data processing. That's going to be the platform people will be running their data science. That's one area where I think like, there will be a huge shift. And the second one is like edge GPUs and AI inferencing, right? As processing moves to the edge, for example, let's say like, autonomous cars or like, even 6G and whatnot, right? If, industry IoT systems. Today, if you look at like, the amount of automation in the industry has stagnated for the past, let's say, in a remote, we're talking to some of the industries they have not even looked at like, automating. For example, a oil rig in the middle of the ocean. You don't have GPUs there. Exactly. You can't really automate. You need to have a person who is actually risking his life, who don't want to be there like, for 3 months. Can we automate that? So edge inferencing, like, can we automate, hey, we can have, if this happens, like, this is how we should respond. And that'll be a person, but far away from the, like, from that oil rig, but still controlling it. And that would be like, for me, an exciting, or like, that would help some of the industries. And the last one is like, just for, I have no idea, but I still think like, quantum computings and GPUs, that's a great research. There's a lot of like, ongoing research of integrating GPUs and quantum computing. I think that will revolutionize that space too. So those are like 3 areas. But the first 2 are like, I'm intimately involved. I know we're going to make a lot more progress.
That's fascinating. Well, Karthik, thank you for taking the time to join the show today. I think it's a really interesting conversation. I think our listeners will enjoy it. Thank you for joining the show.
Thanks so much, Molly. I appreciate, like, I learned as much as, like, from your insights too. I look forward to, like, talking to you again.
Sounds great. Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.